In today's session, Ofer Shezaf will take us through Extend and Manage ASIM, developing, testing, and deploying ASIM Parsers. Ofer is a principal product manager with the Microsoft Sentinel team. And without further ado, I'll turn it over to him. Ofer, the floor is yours.
Thank you, Jason, and good day, everyone. Let me share my screen. And go to presentation mode. Don't worry, I'll switch to browser and demo from time to time. So my name is Ofer Shezaf. I've been leading Sentinel's normalization project, ASIM, for last year or so. We crossed a milestone last month. Now our parsers are deployed, or a large chunk of our parsers are deployed by default with Microsoft Sentinel, which means we are built-in and much easier to use. One thing to keep in mind is that this is the second part. I'm not going to talk a lot about what ASIM is and how to use it. It's about developing for ASIM. You may want to start with the previous webinar that we did 2 weeks ago to get started. So that's for people who already know something about ASIM. It's also pretty techy. Apologies for that. So if you enjoy the techy part, it's great. Otherwise, happy to try to answer questions. We do have a special challenge today. A lot of congratulations for my lead engineer, Yaron Fuchtman. His wife gave birth yesterday morning, but it means that we miss him here on the channel to answer questions, so we'll be a bit light on that. I promise afterwards, when I'm not speaking, to cover up and answer everything, and we'll find the right way to send it to you all. And of course, I'll try to leave a few minutes for questions at the end. So vote up, as Jason said, for the questions that are you really like to be asked verbally at the end. The last thing, it's technical. It calls for a training lab, which I did not create yet. And I don't think a webinar format is good for training lab. I try to get to that. That said, it's a very open project. All the information is available out there on GitHub. If somebody else steps into creating a training lab, thumbs up. I'm here to support you. So let's start. One slide taken from the previous presentation about ASIM and what it is. So today, ASIM is our normalization implementation. It's implemented as at query time using Logalinks functions, which are serve as parsers and normalizers. They run on tables, the Logalinks tables, and they provide a unified normalized view to the content at the top. We'll focus today on how to build and maintain those parsers in the middle, getting the details on this box. So let's start with what are parsers, and to be a bit less boring, let me go into browser mode and talk about them. So we have two types of parsers or level of parsers. The first one would be a KQL function. A KQL function is a piece of KQL that takes a table. Since this is a parser for a Azure Firewall, which logs into the Azure Diagnostics table, it takes the Azure Diagnostic table as a starting point. And then it does a lot of magic with it, which we'll talk about in this webinar today, and enables you to see a view of the data, which we'll see a bit in a demo in a minute, that's normalized. Okay, now because it starts with an underscore, you can see this name here, the top starts with an underscore. It means this is a built-in version of the function that you cannot modify or change. We'll learn a bit today about how to change stuff. If you go here and try to save it, you can save it, a copy of it, but you cannot save the query itself or update it. This one is a version of the same function. By the way, you can always find those functions here on the left. Those are the built-in ones with the underscore, and below them the functions without an underscore that have to be deployed from GitHub. The first bunch always there. This is a version of the same function that you can actually save. So you can save it after you did any changes, you edited, you adapted it to your changes, and then you just save it and a new version is created. So those are functions. Those are functions can be called I don't think I have firewall data here, but they are called from a unifying parser. In the built-in version, we have two levels of unifying parsers. First of all, we have a function called ASIM underscore DNS built-in. We'll talk a bit in a minute about the ASIM and IAM versions, which is a bit confusing complexity we introduced and we need to think about. And this function just called all the other ones. You can see the firewall one here, as well as all other sources you've been, the DNS sources that we support. This means that when you run the ASIM built-in function, you get results from all of those tables together. That's the value proposition. On top of that, we created another one. The reason is, I'll explain in a second, that takes another union and unified ASIM built in with two other functions. The interesting thing here, we get to towards the end, that those two functions don't have an underscore at the beginning, means you can create and update them. That's your opportunity to modify and change the way that the built-in parser infrastructure works. But let's just summarize. Getting back to my slide deck. We have the source-specific parser, which is KQL that knows how to take a table and normalize it. And we have the union parser, which has two levels in the built-in version that just take a union of all those and create a single view from them. Now, we have too many versions of the parsers. There are always a reason, but I'm aware that it makes things complicated. I mentioned that we have built-in functions that start with an underscore. They're always there. If you'll create or open your workspace, you'll see them, which means they're very useful. You can count on them to be there, and you create your queries with them. If you create a workbook or a detection query or a hunting query, you can always depend on them to be there. Those are those that you really need to use. You can also deploy a copy from GitHub. It's the same thing. We create the built-in ones from the version in GitHub, which is like analytic templates, the source of truth. Obviously, the workspace deployed ones may be a bit more up to date because built-in ones take time to get updated. And that's one of the advantages. Sometimes you need the latest and greatest. Also, if you develop, as you've seen before, workspace deployed functions are those that you can edit and save. Okay, so I assume that most of you will use the built-in functions. The workspace deployed ones are there in case you need a version that we don't provide or to modify things, and we'll talk about how to modify in a couple of seconds. I did mention that there are also two types. One starts with IAM and one starts with ASIM. I will demonstrate. I don't know why I prepared the screens with both, but in practical life, use the ones that start with IAM. I'll try to make that clear in documentation as well. So when you use parsers, I demonstrated last week, you just write IAM DNS and get results, and it's easy, I hope, but you may want to develop your own parsers, which is what we're going to talk about today. So for a start, let's talk about why would you like to develop parsers? And there are a few use cases in which you want to develop parsers. You have a device that sends events. The events fits an ASIM schema. Say you have a firewall that sends network session events, but we did not build a parser for that. It's worth checking if it's on the roadmap, if we are planning to, but generally speaking, you need it now. So you can create a parser. Sometimes it's very easy. Sometimes it's really straightforward. So why not? The existing parser may not work for you because you have an unstandard way of using the device, or because you upgraded the version and our version and our parser support an older version of the device, or that the events are received in slightly different format because something in the middle changed them. You might also be a partner in ISV. You have your own device and you want to work with us on creating a normalized parser in your integration solution with Sentinel. If you are up to any of those, you'll have to develop the development process, and it is a development process. The steps here are all, well, writing code as you design any project. It shouldn't be a very long project, but it does require you to follow the steps to ensure quality. I'll talk about each one of them, but before I do that, and to sort of make things a bit more interactive, I'll show you, the whole process end to end using the demonstration video, which I demonstrated last time, but out of context. Now it's really in context. So,
one thing to highlight here is the importance of the Advanced Security Information Model, or ASIM, which is the guiding framework to which normalization happens within Microsoft Sentinel. Let's take an example of a hypothetical proprietary network solution and see how we can leverage ASIM to easily apply existing detections on this custom data source. Here, I'm ingesting a custom network log that provides two main fields, one event info and another being the event message. Now, looking into the message field, there is some consistency in the way the entries are being written. And what we can do here is to use the parse function, which allows us to essentially build a key value pair and match the structure of the entry into the different components we would like to extract. So herein, you'll notice we're extracting network protocol, which would be TCP or UDP. We have and will exclude the request from text and continue to pull out things like source IP address, port number, etc. Alternatively, you could use regex parsing as well if preferred. Running this, you'll notice that the long entry has now been parsed neatly into our desired columns. Coming back to the other field of interest, which was event info, just from visual inspection, we can observe that a good delimiter to use in this case would be a space. In such a case, we can leverage another parsing mechanism called split, which will break out the text entry using a space as the delimiter. Running this, you notice now that we have a very neatly parsed array containing the three different event info components. So let's say I was only interested in these two fields. We can simply click in and extend the two columns. Now, before we rename these fields, it would be useful to look into the ASIM network model to understand what are the available and preferred field names. Coming back to our original parsing query, we can now rename this into destination zone, and the second one we'll rename to network session ID. Running this, you'll notice that destination zone and network session ID have been pulled out. So let's just add a couple of finishing touches. You notice in here that my log source did not provide an event vendor name, but I would like to identify what this log source is, and we can do so by extending and appending a custom name for this event vendor. And perhaps you'd like to store your raw data neatly in one column. We can use a pack function to do so. And let's project away any temporary columns for cleanup. So here, you notice we end up with a very neatly parsed event package, drastically different from what we had originally, rendering it much more usable, while still retaining our original data as well. What we'll do next is to save this as a function, and let's call it ASIM Network Session Custom. The next thing we need to do is to go into the ASIM Network Session function and add our custom parser into the union. This function essentially identifies which underlying data sources should be abstracted into the broader ASIM network group. So now, if we were to query the ASIM network session table, we're able to immediately access all other underlying network data sources, whether it be Palo Alto, Zscaler, Linux Sysmon, and more. Using this partition query, we're just going to showcase two entries per unique event vendor. And you'll notice we have Palo Alto here, Microsoft VM connection, and of course, the proprietary network solution we just added.
So, as usual, things look very easy when somebody demonstrates them. In this webinar, we'll try to look into the details. It's not very hard, but it's not as easy as the 3 minutes video. So let's start. We'll talk about preparing and what's needed before you start. Designing, which means that you need to actually do the mapping, decide what the parser does. Then you need to develop the KQL, which is what you've been thinking about. There's KQL, somebody has to write it, but it's very important to also test it. And we have built some tools for you to actually do testing. So I'll try to focus on that rather than teach KQL again. Then, the video talked about saving functions. Of course, that doesn't scale to an organization. So we'll talk about a bit of more professional deployment and integration. Let's start. And demo was what I just did. Preparing. Probably the biggest hurdle in creating parsers is that you need data. Now, if you own the device, if you're building for an existing device you anyway use, you have the data there. It's a big advantage, and therefore sometimes it might be much easier for you to build the parser than for me to build for you the parser. You have your data. That said, if you are building a parser from scratch, if you still don't have the device, you're just planning for that, if you're building solutions for others, it might be worth to note that you will need to set up the source device. You may want to look, when I started, I'm not that young, as you can see the picture, it was you had to acquire a system, get a license. Today, the pay-as-you-go services on Azure enable you to deploy most devices for a limited amount of money for testing. And develop documentation can also help. You don't want to just generate samples. You want to make sure that they cover all variations. Talking about variations, you should really, to get a good parser, you should make sure that you get all types of logs. So take a firewall. Don't get just accept logs. Get also block logs. You have an authentication event. Make sure that you have a login successful and failure event. You need to simulate any version of the event that the host may generate, that the system may generate. So that's very important. Now you already have the sample data. You can see what the data looks like. The second step is to design to map your sources to a schema. I suggest as a way to work that is to use a great Microsoft product that really serves the purpose as any other purpose, Excel. Having a table where you'll have the schema, which you'll take from our documentation as the video presented, and put it against the fields that you get or can extract using parsing from your source is probably a very important step. Once you have the Excel ready, the rest will be much easier. So how do you map? What do you map to? So the first thing you have to do is decide what schemas your source match. I mentioned network activity for firewall. I mentioned authentication. In the next slide, is it the next slide? Yes, we have a list of schemas that you may be able to map to. If it's not here, we are not ready with ASIM for it yet. The network and endpoint suite cover a lot of activity, but not everything. Some things are not today yet normalizable with ASIM. We are working on that, and we are happy to get your feature requests to get full coverage. The biggest area which is missing is audit events, policy changes, etc. We start with user management, which is a good start. Now, after you selected the relevant schema, you have to map fields. And to get good value from your data, from your source, you want the parsers to map as many fields as possible. It's usually very easy to map, well, to IP addresses. And it provides value, but not all the value you can get. So, for example, we'll see later on that we have classes, we have mandatory fields. If you didn't map mandatory fields, your parser may not work well with existing built-in analytics. But if there are optional fields, your analyst will get a lot of value from you mapping those as well, because it means that you'll get the data in a predictable, easy-to-use manner. Talking about field classes, I mentioned there are 3. When we go to testing later on, we'll see that we actually test for that, and our yet unofficial exception criteria are based on that. Mandatory fields are fields that have to be in the parser. If the source data does not include that, or if the data cannot be generated not based on the source, which we'll see is also an option, there is an issue here. Maybe the schema does not fit your source system, or that the source system data is not useful enough. Consider a firewall that does not report what it did with the event, so the device action, as we call it, or an authentication event that doesn't say if the authentication was successful or failure, or an authentication event that doesn't have a username. All those are events, but they are less useful for analytics and therefore might not benefit from normalizing. Recommended fields are fields that we think you should map to add significant value if available from the source, but nothing would break if they're not there. And optional are a long list that can be phase 2 of the project, but since you never get to phase 2, probably worth doing them upfront if possible. Most fields are optional. Schema can have 100 or 200 fields, most of them optional. They allow for the different variations between sources that we encountered while developing ASIM. So we talked about fields. You have to map the fields. You have to map fields based on field classes, but the field naming is not the only thing which is important. It's important to value normalization. One of the things that we are very aggressive about, I should use a different word, I'll stick to aggressive about, with with our acceptance criteria as well as with the parsers recreate, is to make sure that values are of the right format and rather than just having the right field names. So I'll go into a few examples of value normalization that are the most important ones. A lot of fields in the schemas are marked as enumerated. It means that they have a limited number of values that they are valid for them. Those may not be the values that you get from your source device. As an example, I mentioned the device action value that maps whatever your firewall did with the network session. We require the values to be one of a list, and we test that in our acceptance criteria. Why? Because analytics has to have a predictable set of values, obviously. So the field on the left are all both mandatory and have a limited set of values that are allowed. I'll leave for one host name for the next 2 slides. I'll talk about identifiers. A big challenge that we see a lot is that an event may have an identifier of a different type or a multiple identifiers. For example, what does the username imply? Is it a domain username as in Windows, or is it an email like UPN, or a short, simple username? For all those, we have a field for the value as well as a field for the type. So the username type listed here, which we would like, if the username is filled in, the type should also be available. Analytics may use it. I mentioned host names. Host names are a big debate in the normalization community across different schema projects. We selected a way that has 4 fields for a host name to try to cover the variations and make things predictable for the query using it. You see that the 4 names are host name, which is a simple host name without a domain, domain name, FQDN, which is tying them together. Since we are in query time, this does not imply duplication because we don't store the data again. And then we also have a domain type, which says how did we store the FQDN. So Windows or FQDN type. We found that in many cases you get a value, and the parser has to do the magic of understanding how to break it into those 4 fields. And the snippet below is a good way to handle that, assuming that you may get a simple host name or an FQDN. Our parsers have a few other examples of possible situations, and we will try to make those available in documentation or just in examples in GitHub. Lastly, is it lastly? Nearly lastly, yes. The last value normalization challenge is that we do require, and we test it in the testing I'll get to in around 10 minutes, that all the values of a certain type are consistent. A few examples, and documentation around the schema always document that. A MAC address has to have colons between the parts, not dashes, for example. Why? Because then when a query checks for that, it is exempt from checking for variations. DNS domains. I don't know if you know, but in the DNS protocol, there is a dot at the end of the domain names. Some systems reported a dot at the end, some do not. We decided our gold standard is no dot to make sure that things are always consistent. Process ID is another example which is sort of challenging. Some Windows systems report process ID in hex, some in decimal. We require it to be decimal. That's normalization, keeping consistency, so that queries are simple, predictable, and is it right without understanding the exact details of the source. I'll leave the other examples for your review. The last element in this mapping exercise is aliases. We do have multiple names for the same value. It makes life easier for the user. When you write a parser, you spend a bit more time in creating yet another extend statement. So you as a writer, as a developer, does a bit more to make it easier for the user. When you meet an alias field, make sure you make the assignment if the original field exists. So I've discussed in some length the mapping. The mapping is, in many cases, the hardest part. Understanding what data is there in the source and mapping it into the normalized field. Mapping to normalized field is actually the easy part. Understanding the source is the hard part. In a way, writing parsers, it means that you as the developer has to be the data analyst, saving the security analyst from this task. It makes the security analyst's life easier by relieving him from the need to understand the details of the data structure. And that's why this part design is probably the hardest and most important in creating a parser. And then you have to go into, well, software project, develop, test, deploy, etc. Let's talk about it a bit. So the parser query. The parser query has 3 elements. The parser query takes a single event and outputs a single event. It doesn't have joins. It has a unions for something I'll mention a bit later, but it's relatively speaking a long and detailed but simple to write a query. It has filtering. It has to select some of the events from the data source. I'll talk about why in a minute. Then it has obviously to do parsing. If, as the example I showed in the demo, has a text field that has multiple important values, you need to parse it. And then it has to map to the right names and values. I will not go into detail around each one of those. I'll just mention a bit on each. It's KQL writing. I just want to make sure you know all the elements are there. I will not go into the technicalities of KQL too much. So filtering. Why should you filter? There are 3 reasons to filter. The first one is that usually your source will have more event types than the one covered by your schema. So if you are parsing security events and you want to parse into the process activity schema, you essentially parse events 4688 and 4689. Or if it's Sysmon, event 1 as the example below shows. This implies that you need to select only those to start with. And then you need to identify the source. With Windows events, it's Windows events, but with syslog, you do need to identify that you're taking just the events relevant to your source from the syslog table. And lastly, unfortunately, I will not have time for that, though it is an important aspect. You do need to implement filtering based on filtering parameters. This is a capability that enables your parser to accept parameters, which I presented last time in the first webinar, and that parser filters based on. The important thing is that all the filtering has to be done first. Specifically for filtering parameters, it has to pre-filter on native fields. In general, all parsing has to be done on native fields before all filtering, has to be done on native fields before parsing. If that's not accurate enough, filter again afterwards. Performance-wise, filter before parsing. Don't forget not to filter by time. It's not a job of the parser. That's the query should do on top of it. Moving ahead into parsing. There are many parsing options. It's KQL writing. The list is here. I'm showing this slide just to talk a bit about performance. The slide that you can review in more detail later on has the list of common parsing operators sorted by their efficiency. If a high ranking operator works for you, it is better, and try to use it. If it's low at the bottom of the list, please try to avoid it. I'll mention one specific area, which is parsejson and parsexml. Those are very heavy in nature, and you need to make sure of two things when using them. First of all, don't use them if you don't need to. If your JSON field has a few values, or if it's in a repeating pattern that can be extracted using parse, use parse. It's much faster. The other thing is, if you use parsejson, use it once. Assign it to a variable. Don't try parsejson 5 times in a query. It will kill your parser. And XML is similar, even worse. Getting into a more complex parsejson challenge. While parsing using parse may work for typical JSON, JSON arrays are a big challenge for parsers. If you want to extract, if the JSON array has a list of similar values, you cannot handle them without doing parse JSON. Moreover, you need some looping mechanism to tie together all the values from the array. It's a complex KQL construct called mvapply, which caters for that. And it's very useful for iterating over an array in this manner. The example on the right does exactly that. I need to extend, I used security alert because it's a common table you'll all have, to dynamic is like parsejson, then this field just once. Keep that in mind. Don't do it again if you need more than once. mvapply is essentially a loop over the results that I just got, and then the subquery runs on each one of those. The way to get all the information back is to summarize over the subquery. This will get you a list of the values you needed. Whenever encountered with a list in your source data, you'll have to use this method. Even more common is the challenge of having multiple variations. I used to say variance, but now it's a word you should not use, so I'm using variations in your events. Say it's syslog and there are 4 formats for the syslog handled differently. How do you handle that? So I'll go immediately into the second option. It's again on the more complicated side. A lot of parsers will not need the mvapply or the variations handling, but here we want to learn how to do everything, so we'll talk about that as well. If you have multiple variations, you may want to start with let's say that we'll do the initial filtering. So we'll take Azure Diagnostics and filter only the Azure Firewall messages and check that the message is not empty. And then you will have a special parser for each version, and your parser will union between them. It's a very good way to do that. If and only if the first line in each subparser is a work clause that ensures that you process only the relevant data. If you do any work before that, it means that you do the work twice or more. If you filter fast, it means that each one of the union branches takes only the data that it can process and parses it. I see I don't have it here, but I should probably add, I'll do it before and ask Jason to update the presentation, a link to this specific query so that you can use it as reference. I'll skip mapping for today because we don't have a lot of time. I want to leave some time for questions. And I'll talk about testing and deploying. So you develop KQL after designing well how the source event maps to the destination event. I talked about the more complex elements in creating the KQL, but in some cases it's just a series of extend or project rename functions, or operators, which I skipped over because I thought they were worth our time. It's then very important to test your parsers. It's always important to test things, but parsers are central. It's not a query that somebody runs. It's a parser. There's a lot of queries that are not even aware of the details of the parser we'll use in the future. So it's very important to test them. What do we test? We need to test the schema, and I'll show you how to do it in a second. There's a tool for that. We need to test that all map fields are of the required type. Fields not of the required type break the union. They don't break the union parser. They create unexpected results. Actually, I can explain why they do that, but it's not good for the parsers. So if you add a non-compliant parser to the union statement that has the wrong field names, type, sorry, names are fine, then you can break the union and kill your analytic queries. That's why we created a tester that will test for each parser that it has exactly the right fields types to prevent that. We also want to know that all mandatory fields are there. If you don't have mandatory fields, it means that some analytics will not work well. We do want to recommend and do warnings on fields that are not recommended, fields that are not mapped. And we do want to show you also extra fields that you may want to consider adding, but that's informational in nature. To test that, you only need the table to exist. Getting back to the sample data that I suggested that you have in the first place, you want also to test with real data, hopefully with all variations. This will enable checking that the values provided by the source really are parsed correctly into the right results. How do we do that? So we have created a tester. Is it here? Yes. We actually created it. That's not the right one. It's in a different window. We have two of them. I'm presenting one here. One is called ASIM Schema Tester. The other is called ASIM Data Tester. The schema one you run over the first. Let me show you where do I get them from. That's actually important. So we have development tools for ASIM, and in the development tools we have the ASIM tester, and here you can just deploy all the needed functions to your workspace. So you run the schema tester by running your parser through the get schema function and then invoking the tester. If I run that, you see I get warnings. There are reasons for that, but it's warnings. Those are known warnings, as well as a lot of info messages, which are about fields that are optional but missing in most cases, and then at the end, usually extra fields. There's an interesting question. Recently, we started to project away the extra fields which are not needed to make the parser simpler. It's a bit, it's a design pattern. When we developed this one, we didn't do that. Maybe it's a good point to edit. Now, since this one is a production one, obviously it doesn't have errors. Our acceptance criteria is that the parser should not have any errors, but and for each warning, there should be a documented reason why the warning was ignored. I'll do a trick. I'll project away a mandatory field. If I do that and run it again, you'll see the tester will identify, hopefully, the missing field and will do an error. There are many different errors that the tester will get. If there are any errors, correct them. It might be a type error or missing mandatory field error, etc. I will not get into the data tester now. The data tester will show you examples, errors such as the device action is not one of the supported values. Your domain name is not a true domain name. I recently ran the tester against a new device we are going to support, and I found out that hostname is sort of taken to be a lot of things. It might be a valid hostname, which is useful in analytics, comparing it to TI, or it might be a descriptive message of the host, the server running my syslog server. And what we did was that we actually added to the parser code that identifies whether it's a valid hostname and stored it in the hostname field only in this case. And otherwise, because hostname was not mandatory for the schema, does not do that, so that queries do not get confused. So going back to my presentation, that's testing. You have here how to run the two testers when you get the deck later on. I demonstrated at least the first one. Keep in mind, our experience that parsers are code. Sometimes it's even complex code. Don't just test. Code review, as you do in any development project, is important. As I mentioned, acceptance criteria, no errors, warnings should be waived. Now, lastly, very importantly, we don't have testing for filters yet, automated. So when you implement filter parameters, the parser should be able to enable the user to filter only a specific IP address. Those they're very important. We do mistakes there. Manual filtering, manual testing is needed. Run the parser with a filter, see that only part of the results, the right part of the results are returned. We have a plan to write a testing tool for filters as well. We didn't get to it. Again, if you want to, it's actually an interesting programming experience with KQL or with Python and APIs if you want. Lastly, so you develop a parser. As the video before demonstrated, you save it as a function and it works. There are two elements to that. First of all, you want to deploy it in a more professional manner or managed manner, and you want to integrate it into your unifying parser. Let me go into that for a sec. We created a tool. It's also in the dev tools here, as far as I recall. A tool that will take YAML files, which have a structure. It's not well documented apart from examples we have. We should go into that. And we create ARM templates from those YAML files. The YAML file includes your queries as well as a bit of descriptive information. And those ARM templates can be deployed the way we deploy tools from the GitHub. So you'll be able to use it from GitHub interactively or through a DevOps pipeline. ARM templates are way more useful. That enables you to convert your function, and the YAML files look something like that. It has the parser at the bottom and then a few fields that tell you, meta information. Most of that is not really used in the ARM template, but it's useful to have. You can save the function. You can create a YAML in an ARM template, which is more repeatable process, and then you'll have to integrate into the unifying parser. The video demonstrated pretty well. Let me get back to where it was. The way to do it, okay, getting back to the ASIM DNS function which you saw before, is to update the ASIM custom DNS custom function with your function. To do that, okay, you can create your whatever you want in ASIM DNS custom, but you can start with, and it's also here in GitHub. Sorry, it's in deploy. So empty custom union parsers. You deploy it from here. Let's say the DNS one. I should have done it before and just show the results to save it 2 minutes, but I wasn't smart enough. And things are. And I have a mistake, so I'll stop it here. I'll go into that's another reason I should. So, anyways, you can update a ASIM DNS custom to include whatever you want. If I go back to the video I presented at the end of the video, do you have the video open? No. So the video, which you'll get a link to, showed how to edit the unifying parser. That would be ASIM DNS custom for you. This will enable your parser to be part of ASIM DNS. And the way to include what you want in the unifying parser and make sure that querying across all sources works for you. There are two important areas which I did not get to today because, well, time is time and they require just more time. And I'll show you where to look for them. If I go to the ASIM how-to documentation, the Manage ASIM Parsers page will tell you how to do that, and the develop one. The first one is you may want to add a new parser, but you also may want to exclude an existing parser. Keep in mind that the built-in parsers are not editable. You cannot exclude them yourself. What you will do, and it's documented here, is you update a watch list that has this name with the right values, which will make sure that the parser you exclude is excluded. So for example, the use case is that you have a different parser for checkpoint firewall. You want to make sure that the built-in checkpoint firewall does not run and yours run. You will add your parser to the right unifying function and you'll use a watch list to exclude the original checkpoint parser as documented here. The second very important concept that maybe a next webinar, we need to think about it, Valon and Jason, is developing the filtering part of the parser. As I mentioned, we do need to support filtering in the parser based on parameters that the parser user passes. The best way to do it today is look at an existing parser and replicate. I've started to work with people outside of my team that work on those. If you get to those, I'd love to hear your feedback. What works for you? Additional information is required. This is sort of the bleeding edge, so to speak, and probably worth to discuss in an upcoming webinar. So with that said, Jason, Valon, it's a good time to wrap up and get into questions, which unfortunately, as you may recall, we probably didn't answer online. I'll get to answer offline. Jason, were there any questions worth relating?
Yeah, definitely. First one is, can ASIM only be carried out in Sentinel, or can you make use of it elsewhere, such as Data Explorer? If so, will there be limitations?
Wonderful question. Thank you. The parsers are pure KQL that runs on Data Explorer. They should work. They're open source on GitHub. We didn't test ourselves. So we'd love to hear whoever asked your experience. There's no legal, shouldn't be technical limitations, but we didn't try. Just to mention, it's specifically true to Data Explorer, of course, because it uses KQL. To use them in other places, and I did get a question about using them in a product called Cribble, for example. It's not KQL. That makes it harder.
Great. Next one is, does this mean that we will have three kinds of analytics, ones which are source specific, ones which target the IAM built-in ASIM parsers, and ones which target the old IAM function parsers, which will be the only ones we, as an MSSP, will be able to introduce new parsers into?
So, okay, it's a good question because it enables to clarify something. The only version that will be out there in the pretty soon for many is the one with the _IAM_ parsers. There's a keep in mind that we only send templates. We don't change your active rules, so the active rules will not change, but the templates will focus on using the normalized version with the _IAM_. Now, you mentioned that you can only modify the version with IAM. Towards the end, maybe after the question was asked, I did mention that using, as I mentioned, I'll show it here again, by modifying ASIM_DNS custom or IAM_DNS custom, you modify the built-in underscore versions. So we did build, and I probably was way too fast on that. Documentation is here, or asking me is a good way around that. We do enable you to customize the built-in parsers by using this hook I'm presenting here. So just to summarize, all analytics will be _IAM. You will be able to, you are able today to introduce your own parsers into it. I hope that helps.
Great, thank you. The next question is, what is the preferred method for developing the ASIM schema? Based on the log source type, based on the detection scope, activity type, what is considered best practice?
So it certainly is not the log source type, because our experience that log sources imply very different activities. So they're not a uniform schema. Best example is Windows. It's a source, but it has so many different things it reports. Between detection and activity, I hope that we did a good job of making them similar, so that you don't have, it's just the same. My experience is usually the actual consuming queries, detections, analytics, they refer to an activity, process create, file deleted. So I hope it's one and the same. I hope you are not in, you don't have to make a choice. If you do have to make a choice, maybe we did something wrong. I'd love to hear about it.
Great. Next one. Say your source matches network normalization schema, but your source does not contain geolocation. Is enriching geoinfo, for example, supported here?
So ASIM itself does not have, it has the fields, but it does not itself support geonormalization. Sorry, geo-enrichment. Enrichment in general is an area we are working on in parallel. Some part of that. You can do that today. So we can go. We can have a watch list with geo enrichment information and look it up in a parser. So it can be done. We did not include it out of the box in anything we do with ASIM. It's a good idea, by the way. We may want to take your advice and start doing it.
Great. Next question Is it the product direction that ASIM will be used in the future to replace the default language for analytic rules, i.e. direct table queries? Or is the intention that ASIM will be used for large data sets and more complex detections and hunts?
So, sorry for that. ASIM is supposed to be the basis for everything because it's the only way to expand the support of any query to way more sources. I don't think it replaces the current language. It does mean that you use a different table name, but it's part of the rules of the language, so to speak. I don't think it changes them. Happy to learn more about why it is considered a change of language, whether it poses a challenge to try to make things better.
Great, and we have time for one more question. As I understand, NetFlow logs are only supported as basic logs on Sentinel, but not for analytics. My questions are: one, is it recommended to use NetFlow logs for analytics on Sentinel, considering these are high volume? Two, if yes, is there any custom parser available on GitHub already for NetFlow logs, or should I just build one using the ASIM network session normalization schema?
So one I probably need to take offline. I don't think we have a NetFlow connector. Why did I start getting email? I closed Outlook. Oh, it's from the browser. It's funny. So sorry for that. So if there's no connector, we don't develop a parser. If there is a connector, I'll be happy to discuss having a parser. We have a whole project around creating parsers for NetFlow-like sources. Some like Vector AI and Zeek are in development. If what you want is NetFlow as sent by Cisco router, we need to look into how to get it into Sentinel in the first place. Anyways, I hope that's it's not a complete answer because I don't think I have the full picture. Thank you for the question. All very good questions, by the way. I enjoyed it. First, Jason, you select the right ones, and secondly, guys, you did have good questions. Thanks for that.
Great. Well, thank you, Ofer, for being our guest today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.